The last two examples don't introduce any new concepts compared to what we've already been talking about. We just have more parts of a question giving us more pieces of the problem that we need to pay attention to and focus our attention on the right portion of the graph. For instance, in example 5, the first three questions deal with what's happening as x approaches 6. The next three parts of the question deal with what's happening as x approaches 5. So again, however we go about doing this, we want to draw our attention to what's happening when x is equal to 6. We can look at as we approach 6 from the right-hand side and see that we're approaching a function value of -2. And as we approach from the left-hand side, we're approaching a function value of 4, which means the limit as x approaches 6 of this function does not exist. For the next three parts, we're considering what's happening as x is approaching 5. So now we want to draw our attention to the vertical space above and below x equals 5. And we can look at the limit as we approach x equals 5 from the right. We see that we're approaching a function value of 5, and we're approaching that same function value from the left, which means the limit as x approaches 5 for this function is 5. And now for the last two portions, we're just asked to identify the function value. T of 6 in this case will be where we have that filled in dot in line with x equals 6, so our function value will be -2. At x equals -5, we have an open circle with no other filled in dots above or below it. So we would say here that the function is undefined, or we could use that same D and E does not exist notation to indicate that there is no function value at x equals 5. Similarly, with example 6, we'll want to pay attention to which part of the graph we should be considering. The first three limit statements deal with what's happening around x equals -2. As we approach -2 from the right, we're approaching a function value of 5. And as we approach from the left, we're approaching a function value of 0, meaning the limit as x approaches -2 does not exist. The next three parts of the problem deal with what's happening around x equals -3. As we approach from the right, we're approaching a function value of -1. As we approach from the left, we're approaching that same function value of -1, which tells us that the limit as x approaches -3 is equal to -1. And then the last two questions, again, ask us about the function value. M of -2 will be equal to 0 since we have that filled in circle. And M of -3, we have an open circle along the curve, but we have this filled in dot down below telling us that there is a function value that's defined here, which would be -6.